Dear students, in this lecture, we will be going to understand that what are the various IS 456-2000 guidelines regarding the design of RCC beam when it is subjected to torsional movement along with flexure movement. So whenever there is any type of beam having structure and loaded in such a way that some torsional movement will be acting on that beam, then we have to design that beam as per IS 456 provisions, and let us try to understand the guideline properly. Now IS 456-2000 recommendations for design of a section which is subjected to shear as well as torsion as well as bending moment. So what code is suggesting that in the design of general RCC structure, normal RCC structure where those are not subjected to any type of torsion, so that we have already gone through in the previous lectures. So in the design of general RCC structure which are subjected to bending moment, that means bending moment is acting on that section as well as shear force is acting, and then what we have done, we have provided longitudinal steel to resist the bending moment and transverse steel or transverse reinforcement to take care of the shear stresses or shear, that are developing due to the shear force. However, when we see in some of the situations where the beams may be subjected to torsion, so then what we have to do, we have to design the longitudinal as well as transverse reinforcement. So longitudinal steel and transverse reinforcement jointly they will resist the torsional movement. Now as per IS 456 recommendation, how we have to do the calculation? The calculation of the longitudinal and torsional reinforcement for a section which is subjected to shear and torsion simultaneously. That means now the section is subjected to or experiencing some torsional movement also. They are not calculated separately now, and we can refer clause 41.3.1 of IS 456-2000 version. Now what we have to do, the total longitudinal reinforcement is calculated based on this theory that is known as equivalent bending moment. That means we are going to calculate equivalent bending moment where we include the flexural movement as well as torsional movement, and this equivalent bending moment which is a function of actual bending moment and torsion. So what code is suggesting that instead of designing the steel separately for flexural movement, that means bending moment, and separately for torsion, instead what we have to do, we will follow the codal advice that is mentioned in clause number 41.4.2, where equivalent bending moment will be calculated. That means we will be going to convert the torsional moment into bending moment, and actual bending moment is acting, so both will be taken into consideration, and based on these both movements we are going to calculate equivalent bending moment, and the section will be designed for equivalent bending moment. And regarding the transverse reinforcement determined based on equivalent shear. So earlier, if the section is not subject to torsional movement, then what we were doing, we were calculating the shear force at a critical section, and accordingly we follow the provisions of the IS code. Now when torsional movement is acting, and then we have to calculate equivalent shear, which is a function of actual shear and torsion. That means torsional movement is acting, and due to that torsion, we are the section will be subjected to some torsional shear also. So based on these two, we will be going to calculate this equivalent shear. So that means transverse reinforcement need to be designed to take care of this equivalent shear. And for this, we can refer clause number 41.4.3. Now what clause 41.4.1 says? It states that the above provision shall apply to beam of solid rectangular section. However, these clause may also be applied to flange type of a beam section also. Then where if you have to design the flange type of a beam, that means just like I section or T section. Particularly T section we are going to design in case of RCC structure. So then what we have to do, we have to substitute the width of web for B in this formula, in which case they are generally conservative. Therefore, special literature may be otherwise you can refer, or the Codal provision we can take into guideline. That means we will be going to substitute the width of web with the width of the beam. Now, what clause 41.2 state? It states that section located less than a distance d, that means equal to a distance equal to the depth of the effective depth of the section from the face of the support may be designed for the same torsion as computed at a distance of d, where d is the effective depth. So this is the another provision which we have to take into consideration while we are going for the design of a section subjected to flexural as well as torsion. Now, first of all, we are going to understand that what are the codal provision regarding the design of transverse reinforcement. So we can refer clause number 41.4.3 of IS 456/2000. So very first point is the transverse reinforcement need to be provided and checked as per this clause 41.4.3. Now you can refer here the snapshot of 41 clause 41.4.3 where it is used to design the transverse reinforcement. So what this clause is saying, two-leg close hoop enclosing the corner longitudinal bars shall have an area cross section that is ASB. So this is the formula which is giving you the guideline regarding the area of the transverse reinforcement required. But the total transverse reinforcement shall not be less than that will be calculated by this formula. So each abbreviation has their own importance. Now, second point is equivalent shear. How to calculate equivalent shear? So we have to refer clause 41.3.1 where the formula for equivalent shear is mentioned. So this is the clause, snapshot of clause 41.3.1, that is to calculate equivalent shear. So equivalent shear VE can be calculated by using this formula, that VE is equal to VU plus 1.6 TU by B, where VE is the equivalent shear which we will be getting. VU is the actual shear, that is the normal shear generally we say, and TU is the torsional movement, and V is the breadth of the beam. So putting all these values, we can easily get value of the equivalent shear. So this is the formula, VE is equal to VU plus 1.6 TU by B. VE is the equivalent shear, VU is shear, TU is torsional movement, V is the breadth of the beam. Now, first of all, from this value VE, that means we have calculated the equivalent shear value. So based on this equivalent shear value, we will be going to calculate equivalent shear stress as per clause 40.1. Clause 41.1, that means tau VE is equal to VE by B into D, as we use in the previous type of numericals. Now what we have to do, second point is we have to check, we have to apply the check whether this equivalent shear stress is greater than or less than tau C max. Tau C max means maximum shear strength carrying capacity of the section based on the grade of concrete. Now third point is if tau VE, that is equivalent shear stress which is obtained from equivalent shear from this particular formula, if it is less than tau C. Now what is tau C? Tau C is the nominal shear stress of the section which is based on the area of steel provided as well as the grade of the concrete, and that percentage of area of steel, based on percentage of area of steel and grade of concrete, we can get the value of tau C from table number 19 of IS 456. So we have to check, we have to apply this check. If this check is okay, if this check is true, then we have to provide minimum shear reinforcement as per clause 26.5.1.6. Otherwise, important point is here, that means if tau V is greater than tau C, obtained from table number 19, Then we have to provide longitudinal as well as transverse reinforcement. Again, we have to refer clause number 41.4. So this is clause number 41.4.3 regarding the design of transverse reinforcement. Now, the design guideline which we have to take into consideration for the design of longitudinal reinforcement. So then we have to refer the clause number 41.4.2. This is snapshot of clause number 41.4.2, that is IS 456-2000 longitudinal reinforcement. Now the longitudinal reinforcement, what code is suggesting, longitudinal reinforcement need to be designed to resist an equivalent bending moment ME1. So ME1 you can calculate by adding MU plus MT, where MU is the bending moment at the cross section and MT is the movement. That means we are converting torsional movement into movement. So that is MT. MT is the movement due to torsion. So MT is equivalent to TU into 1 plus d by b upon 1.7. So where in this equation TU is the torsional moment, capital D is the overall depth of the section of the beam, and V is the breadth of the beam. So what we are going to understand here, that means what are the various guidelines we have to adopt for the design of longitudinal reinforcement. So torsional moment TU, as we have discussed here in clause number 41.4.2, we have need to convert this TU into effective bending moment, that is MT. So MT, which we have discussed. Yes. Now second point is, after calculating this effective bending moment MT, we have to find out equivalent bending moment, that is ME1 and ME2. We have to do two calculations. So first one is ME1. ME1 is the addition of MU plus MT. So what you have to do, you have to first of all need to calculate equivalent bending moment ME1, which consists of the addition of MU plus MT, which we have discussed so far. And the second is ME2. We have to calculate, that means we have to subtract MU from MT. So these two values we need to calculate. So these guidelines are mentioned in this clause number 41.4.2.1. Now few information is very relevant which we have to understand here. So what this clause is suggesting, if the numerical value of MT which we have calculated as defined in this exceed the numerical value of movement, so that we have to check here whether MT is greater than MU or MT is less than MU. Now if MT is greater than MU, then ME2 will be positive value. Now what we have to do, we have to the longitudinal reinforcement need to be provided on the flexure compression face, such that the beam can also withstand an equivalent movement, that is ME2, given by this formula. So now let us elaborate it in detail. So what is third point? The longitudinal reinforcement which we have to provide need to be provided for ME1. So that means first of all we will calculate ME1, and based on that we are going to get the area of steel. So that area of steel we need to provide in the flexural tension zone. Now fourth point, in addition, if MT is greater than MU, that means movement due to torsion is dominating the bending moment. So definitely then ME2 will be greater than 0. So what code is suggesting, the longitudinal reinforcement need to be provided for ME2. That means whatever the value of ME2, then we have to calculate AST2, we can say area of steel required. And this steel which is getting from the ME2 need to be provided in the flexural compression zone. Now very important point of consideration here is ME2 shall be taken as acting in opposite sense to movement MU. That means if the steel you need to provide for MU in the lower face or lower part of the section, then ME2 you need to provide in the upper part of section, or relevant we have discussed here, That means flexural tension as well as flexural compression. So if there is another case where mu is 0, if you are going to design that section where flexural bending moment is 0, then we will say it is a case of a pure torsion. That means only torsional movement is acting, not flexural movement. Then what we have to do, the equal longitudinal reinforcement is provided in tension and compression zone for bending MT. So based on the value of MT, we need to find out the area of steel, and that area of steel in equal amount we need to provide in compression as well as tension. Now, what are the codal provision for the design of transverse reinforcement? That is clause 41.4.3. So the transverse reinforcement need to be provided and checked as per clause number 41.4.3. So this we have already discussed in the previous slide also. Now let us elaborate it. So what code is saying, two leg closed hoop transverse reinforcement is provided in such a way that closed hoops should surround or enclose the corner longitudinal bars and having an area cross section at least equal to ASV. Now you will be able to understand in the next step. This is the formula for calculating the area of steel need to be provided for the transverse reinforcement. So this will be the sectional diagram here. This is a beam section having width B and overall depth capital D. Now TU is the torsional moment, VU is the shear force, SV. Now what is SV here in this equation? SV is the center to center spacing of the stirrups. Now what is B1 here when you have to do the calculation? B1 is center to center distance between corner bars in the direction of width. Now this is the direction of width. Here you can see there are two corner bars. So V1 will be the center to center distance between these two corner bars. Similarly, D1. D1 is the center to center distance between corner bar in the direction of depth. So, from this diagram, it is very much clearly visible that corner bar in the depth side, in the depth direction. So, center to center distance, we need to calculate D1, that we have to substitute here. So, to calculate ASV, TU we have already there. SV is the center to center spacing of the stirrups. VU is the shear force. And V1 D1 we have already discussed. Fy is the yield strength of the steel which you are going to use. Fy is the characteristic strength of stirrup reinforcement. Now here we have to apply the check for the minimum area of transverse reinforcement. So this is the formula already given in the code. That means the area of steel should not be less than this. This is the minimum area we have to. Now in this point we will be able to understand it more clearly. So this is the minimum area of steel. That means this ASV must be greater than or equal to this. So when we take ASV equal to this formula, after calculation from this formula, that is the minimum steel. Now we have to refer clause number 26.5.1.7 where SV, to calculate the SV, the maximum spacing for transverse reinforcement when provided as torsional reinforcement. So here you have to calculate that first of all we need to calculate x1 which is given here, then x1 plus y1 by 4 or 300. So whatever be the value you will going to calculate here. So SV should be less than or equal to the highest of this value, and x1 y1 and the short and longer distance we have already discussed. So after that, as per clause 26.5.1 B part, in the first it was A part, now it is B part. What B part suggests, the longitudinal reinforcement shall be placed as close as possible to the corner of the cross section. So here we have provided nearly corner to the cross section in all cases. There shall be at least one longitudinal bar in each corner of the ties. So that means at least one bar we need to be provided here. Now if the torsional member has a cross section dimension, that is overall depth rather than width, if it exceeds 450 mm, that means if the depth of the section exceeds 450, it is more than 450, then we have to provide additional longitudinal bars, that is known as side face reinforcement, and with area not less than 0.1% of the web area or the beam area. So you have to uh, keep in mind here that if the beam section is not subject to torsion, then for side face reinforcement, beam depth should be more than 750 mm. But if it is subjected to torsion, then the beam width must be, if it is greater than 450 mm, then you need to provide the side face reinforcement. And what another guideline, these bar that you need to be provided should be distributed equally on the two faces at a spacing not less exceeding 300 mm or web thickness, whichever is less. So what is the meaning of this statement? That means you have to calculate the area required as a side face reinforcement. That will be 0.1% of the web area, and that area will be equally divided into the two faces. So that means this face, yeah, suppose you are getting two number of bars. So one bar you have to provide in this face and another bar you have to provide in another face. Thank you.